Hello everyone. Let's see the numericals on elevation of boiling point in this module of the chapter solution and colligative property. The numerical is this. A solution containing 0.5126 gram of naphthalene having the molar mass 128.17 gram mole inverse in 50 grams of CCl4 gave a boiling point elevation of 0.402 Kelvin, while a solution of 0.6216. In this case, it means that there are two solutions. One is a solution of naphthalene in CCl4 and the second is a solution of 0.6216 gram of unknown solute in the same mass of the same solvent. So one case the solution is naphthalene and CCl4, and in second case it's a solution of unknown in CCl4. Anyways, let's read the second solution. While a solution of 0.6216 gram of an unknown solute in the same mass of the same solvent gives a boiling point elevation of 0.647 Kelvin, find the molar mass of the unknown solute. Let us first go with the given, the solvent. The solvent in both the solutions are same, so let me say solvent is 1, that is CCl4, its molar mass is 154 gram mole inverse. The second thing is about the solute. In first case the solute is naphthalene, so let me say solute 2 is naphthalene, and let me give a new term, that is 3 for the next solution solute. So I can say solute 2 is naphthalene, its molar mass is 128.17 gram mole inverse, and the solute 3 is unknown. So you have two solutions, solute 2 in solvent and solute 3 in the solvent. Let's go ahead with the data. The first data is about the solute 2, which says that its weight is 0.5126 grams. So W2 is 0.5126 gram in 50 grams of CCl4. So W1 is 50 grams, that is 0.05 kg. Gives an elevation of boiling point 0.402. When the solute 2 is added in the solvent, the elevation of boiling point is 0.402. So delta TB for solute 2, I am saying delta TB2 is equal to 0.402 Kelvin. Similarly, let us go ahead with the data of solution 2. First thing, the weight of 3, that is weight of solute 3 W3 is 0.6216. The mass of the solvent is same and the elevation over here is given as 0.647. So delta TB3 is 0.647 for solute 3, that is unknown, and what exactly we are supposed to calculate? We need to find the molecular weight of the solute 3. With this data, let us go ahead with the formula. Since we need to find the molecular weight, the formula which we are going to use is this: delta TB is equals to KBW2 upon MW2 into W1. But how will we get the answer? Now there are two solutions. From the first data of our solution 1, we'll first calculate the value of KB, because if you see from the first data only KB is missing. Now once you get KB value for solution 1, since the solvent being common, the KB value will be same. So I'll get the value of KB from solution 1 and I'll use the value of KB for solution 2. So let us first calculate the value of KB. Since I have the formula delta TB is equals to KBW2 upon MW2 into W1, for solute it will become delta TB2. Correct? From here I'll get the value of KB as delta TB2 into MW2 into W1 upon it is W2. Let us substitute the values. What do we get? 0.402 into 128.17 into 0.05 upon the value of W2 is 0.5126, and on solving I get the answer of KB as 5.0257 Kelvin kg mole inverse. Now I'll going to substitute this value of KB in the equation of the second solution. So the second solution equation is delta TB3 is equals to KB W3 upon MW3 into W1, where the value of KB is 5.0257 Kelvin kg mole inverse. Since I need to find MW3, my equation will become KB W3 upon delta TB3 into W1. Let's substitute the values. It is 5.0257 into 0.6216 divided by it is 0.647 into it is 0.05, and this will give me on solving 96.567 gram mole inverse. That's how we calculate such type of numerical. Let us take a multiple choice question. The question is, KB of water is 5.13 degrees Celsius gram mole inverse of water. When 0.1 mole of sugar is dissolved in 0.2 kg of water, the solution would have the boiling point of These are the following options. Let us go ahead with the entire data. Ideally, the formula which I'm going to use to calculate is something called as delta TB is equals to KB W2 upon MW2 W1, where first of all I'll discuss the units. MW2 has to be in gram mole inverse, W2 has to be in grams, W1 is in kg, delta TB can either be Kelvin or degree Celsius, and KB has to be Kelvin kg mole inverse or degree Celsius kg mole inverse or Kelvin per molal or degree Celsius per molal. Now, first of all, if you see, the value of KB given is 5.13 degree Celsius 100 gram mole inverse, which is not matching. It has to be degree Celsius kg mole inverse. So I have to correct that. So I'm going to write this as KB is equals to 5.13 degree Celsius. In place of 100 grams, I'm writing 0.1 kg mole inverse. So 100 gram is as good as writing 0.1 kg. I'm now going to pull that 0.1 in the normal number. What do I get? 0.513 degree Celsius kg mole inverse. Now the units are proper. I'll go ahead with my calculation. Delta TB is equals to KB N2 upon W1. Why I'm using this formula N2 upon W1? Because in the question number of moles is given. Let us go ahead with the entire thing. So delta TB is TB minus TB naught is equals to KB N2 upon W1. Let us substitute the values. Do I know the value of what is TB and TB naught? Actually, I need to calculate the value of TB, and TB naught is 100 degrees Celsius. KB is 0.513, N2 is 0.1 upon W1 is 0.2 kg. So when we solve this, the right hand side will become 0.2565, and the value of TB naught, as I told you, it's a boiling point of water, has to be 100 degrees Celsius. So the value of TB will be 100.2565. My answer is B, option B. That's all we have for this particular module. Thank you so much.